Students, we are studying in previous class about oxidation of alcohols, dehydration of alcohols. In dehydration of alcohols, we are studied the dehydration of primary alcohol by using by oxidation by using PCC, then oxidation by using MnO4, oxidation of secondary alcohol by using CrO3, and oxidation of tertiary alcohol using alkaline KMnO4. In dehydration, it's dehydration of primary alcohols, secondary alcohols, and tertiary alcohols. So in dehydration, we are also studied the mechanism of dehydration of primary alcohol or ethyl alcohol, and that mechanism is important from the point of examination. So after this, we have to discuss some dehydrogenation of alcohols. There is a difference between dehydration and dehydrogenation. In a dehydrogenation, you are removing the hydrogen from alcohol, and dehydrogen is done by using copper or silver catalyst at 300 degrees Celsius. So let us discuss some dehydrogenation of alcohol. Dehydrogenation of alcohols. Well, the first one is dehydrogenation of primary alcohol. Dehydrogenation of 1 degree alcohol. So your 1 degree alcohol undergoes dehydrogenation, when passed over Cu or Ag at 300 degrees Celsius. It is nothing but 573 Kelvin to give aldehyde. So what you have to remember, formation of aldehyde by dehydrogenation of 1 degree alcohol. And what's the catalyst? Catalyst is copper or silver. We know the general formula for 1 degree alcohol, RCH2OH. It is 1 degree alcohol or primary alcohol. It undergoes dehydrogenation when passed over copper or silver. It may be copper or silver at 300 degrees Celsius. Product is aldehyde, and dehydrogenation means elimination of H2 gas. Second, dehydrogenation of secondary alcohol. Dehydrogenation of 2 degree alcohol. So 2 degree alcohol on dehydrogenation in presence of CuREg at 300 degrees Celsius gives ketone. So important is ketone. Then 2 degree alcohol or secondary alcohol in presence of copper and or silver. So we know the formula for 2 degree alcohol, R2CHOH, or is RCHR-OH. So in presence of copper or silver, CuREg at 300 degrees Celsius, product is RCOR. It is nothing but ketone. Ketone is the product. This one is aldehyde. One more is dehydrogenation. That is removal of H2. Third, so 1 degree alcohol on dehydrogenation gives aldehyde. Dehydrogenation means you have to remove H2 from the alcohol. So when H2 is removed, remaining is RCHO. When H2 is removed, remaining is R2CO, or it may be RCOR dash. That is ketone. But in case of 3 degree alcohol, that is for the tertiary alcohol do not undergo dehydrogenation. It is due to the absence of tertiary hydrogen. So the formula of the tertiary alcohol shows the absence of tertiary hydrogen. So do not undergo dehydrogenation. Instead of dehydrogenation, it undergo dehydration. So 3 degree alcohol do not undergo dehydrogenation. It undergo dehydration. To give alkene. So to give alkene, when passed over CuREg at 300 degrees Celsius, or it may be above 300 degrees Celsius, do not undergo dehydrogenation. It undergo dehydration to give alkene. Condition is in case copper or silver at 300 or above 300 degrees Celsius. We know the formula for tertiary alcohol. It is R3CHOH. Instead of that, I am writing like this: R, then it is OH. So we don't find hydrogen on this carbon. That is, there is no tertiary hydrogen. So do not undergo dehydrogenation. Instead of that, it undergo dehydration when passed over copper or silver at 300 degrees Celsius to give alkene. Alkene is the product. One more is H2O. Remember, not H2. H2 is not formed, so underline that one. It is H2O. So example, CH3, CCH3, CH3, OH. So it undergo dehydration. Tertiary alcohol undergo dehydration at about 300 or more than 300. So it gives the alkene. I am writing CH3, C double bond CH2 CH3, one more is H2. Well, the name of this hydrocarbon or alkene is, we have a double bond, we have a ENA group or alkene, to number it 1, 2, 3. So it is 2-methyl propene. Name is 2-methyl propene. You can write any example for this 1 degree and 2 degree alcohol. So I am writing the example here. Example is CH3OH. So dehydrogenation is remove the hydrogen gas. So when passed over copper or silver at 300 degrees Celsius, the product is HCHO. So aldehyde form contains the number of carbon atoms as there are in alcohol. We know this is called formaldehyde or methanol. An example for next one, for secondary example. So it's a CH3, simple example I am getting. CH, then it is CH3 OH. We know name of this compound. It is isopropyl. We have 2 CH3 attached to CH, so it is isopropyl alcohol, or it is propan-2-ol. When passed over copper or silver at 300 degrees Celsius, the product is CH3, COCH3 and H2 gas. So it is acetone or propanol. 1 degree gives aldehyde, 2 degree gives ketone, both are dehydrogenation. 3 degree undergo dehydration to give the alkene. So this is about dehydrogenation. That means we can distinguish 1 degree, 2 degree and 3 degree alcohol by this reaction. This is because when the alcohol, any alcohol is passed over heated copper or silver at about 300 degrees Celsius, the product formed is aldehyde, then you may conclude that the alcohol is nothing but the 1 degree. Second, if the ketone is formed, then alcohol is 2 degree, that is secondary. And if the alkene is formed, then alcohol is tertiary or 3 degree. So you can distinguish this primary, secondary and tertiary alcohol by this reaction. We have one more reaction. Use it to distinguish between 1 degree, 2 degree and 3 degree alcohol. That reaction is called Lucas reaction, or the reagent used is called Lucas reagent. So it's also called Lucas test for alcohol. So we have 3 types of alcohol: primary, secondary and tertiary. We know in case of tertiary, the carbon is attached by 3 different groups or identical groups. For example, it is tertiary butyl alcohol. Carbon is attached by 3 CH3. So here CH3 or alkyl group is electron donor, and when we have a greater number of electron donor atom, the carbocation formed by the elimination of OH is more stable. So tertiary carbocation is more stable compared to secondary carbocation, compared to primary carbocation. That means the reactivity order of the tertiary alcohol with the Lucas reagent, it is a mixture of ZnCl2 and concentrated HCl, is greater than secondary alcohol and greater than primary alcohol. Now, so we have to discuss the distinction between 1 degree, 2 degree and 3 degree alcohol using Lucas reagent. So distinction between 1 degree, 2 degree and 3 degree alcohol using gas reagent. Distinction between 1 degree, 2 degree and 3 degree alcohol using Lucas reagent. Using Lucas reagent. So what is Lucas reagent? Mixture of N-nitrous ZnCl2 and concentrated HCl. Mixture of Lucas reagent. Lucas reagent is a mixture of N-nitrous ZnCl2 and concentrated HCl. What you have to remember? What is Lucas reagent? That is alcohol plus Lucas reagent. It may be 1 degree, 2 degree or 3 degree alcohol. We know reactivity order is different. Turbidity appears immediately. Turbidity appears immediately for 3 degree alcohol or tertiary alcohol. Then turbidity appears after 10 to 15 minutes for 2 degree alcohol, and turbidity appears only after heating. For 1 degree alcohol. So we can distinguish if the alcohol is given to you and asked to identify what type of alcohol. Just take alcohol in a test tube, add Lucas reagent, a mixture of N-nitrous ZnCl2 and concentrated HCl, mix it. If turbidity appears immediately, then it is tertiary alcohol. And if the turbidity appears after 10 or 15 minutes, then you may say the given alcohol is secondary alcohol or 2 degree alcohol. If turbidity do not appear even after mixing thoroughly, then you may say it is primary alcohol because it appears only after heating. So this is the distinction between 1 degree, 2 degree and 3 degree alcohol. Well, afterwards we have to discuss on the manufacture of methyl alcohol or methanol and ethyl alcohol. We know methanol is nothing but it's also called wood spirit. And how it can be obtained? When in first year we were studied about water gas. Water gas is a mixture of carbon monoxide and hydrogen. When that mixture, compressed mixture at about 300 atmospheric pressure, when that mixture is passed over ZnO and Cr2O3 at about 600 Kelvin, you are getting methyl alcohol. So this is the commercial method used to manufacture or to prepare methyl alcohol. And remember, methyl alcohol is also called wood spirit because in olden days it was obtained by distillation of wood dust. So it's also called wood spirit. Well, let us discuss on methanol and ethanol. That's methyl alcohol and ethyl alcohol. Methanol or methyl alcohol. Methanol. Methanol or methyl alcohol. Methyl alcohol. Remember, it's also called wood spirit. Wood spirit. Don't get confused. So, which one is wood spirit means it is methyl alcohol or methanol. Preparation or manufacture. So, methanol is prepared. Methanol is prepared by passing mixture of CO, that's carbon monoxide, and H2 over ZnO and Cr2 3 under pressure of 300 atmosphere at 623 to 673 Kelvin. So just by passing a mixture of carbon monoxide, remember CO means not cobalt, both are total, carbon monoxide and hydrogen, it is also called water gas, over ZnO and Cr2 3 under pressure of 300 atmosphere at 623 to 673 Kelvin. So equation is mixture of CO and H2. It is called water gas also. It is also called water gas. When it is passed over ZnO and Cr2 3, ZnO plus Cr2 3 at under a pressure of 300 atmosphere at a temperature of 623 to 673 Kelvin. The product is CH3 OH. You can balance it. It's easy because only one product is formed. Number of carbon is 1, oxygen is 1, hydrogen are totally 4. That means you have to write 2H2. So product is methanol or methyl alcohol. It's also called wood spirit. Methanol is colorless liquid with a spirituous odor. It is poisonous. It causes blindness. It is used as a solvent in paint and also for some organic reactions. Well, then it is about ethanol or ethyl alcohol. Ethanol or ethyl alcohol. Ethyl alcohol. Well, generally you are manufacturing ethyl alcohol or preparing ethyl alcohol on large scale from sugar or from molasses. Molasses is nothing but a dark liquid left after the crystallization of sugar in sugar industry. So it contains about 50% of sucrose, that's non-crystallizable. We know sugars are nothing but crystals. It is non-crystallizable. It contains about 50% of sucrose. From that, alcohol can be obtained. Method is very simple. So molasses is diluted to water, then yeast is added. So yeast secrete two enzymes, that is gymase and invertase. In presence of enzyme invertase, the conversion of sucrose into glucose and fructose takes place. Then glucose and fructose are converted into ethanol by the enzyme gymase. Both these enzymes are secreted by yeast. So this on distillation you are getting about 95.5% of alcohol, and it is called rectified spirit. 100% alcohol is called absolute alcohol. So it is a manufacture of ethanol or preparation of ethanol from molasses. Manufacture from molasses. So molasses is diluted to water. Molasses is diluted with water. Yeast is added. Its secret enzymes. Yeast is added. Secret enzymes invertase and gymase. This mixture is kept for 3 days at 30 degrees Celsius for fermentation. So it's a fermentation of molasses takes place. In presence of enzyme invertase sucrose, or you may say sugar, hydrolysis to or convert, you can write hydrolysis to glucose and fructose. That is sucrose, formula is C12H22O11. Undergo hydrolysis means interact with water in presence of enzyme invertase. Product are glucose and fructose. Both are having formula C6H12O6, but functional groups are different. C6H12O6. So it is glucose and one more is fructose. Glucose and fructose. And afterwards, glucose and fructose are converted into alcohol, that is ethyl alcohol. and glucose and fructose are converted into ethyl alcohol in presence of enzymes. The question is, we know the formula for glucose or fructose C6H12O6 in presence of enzymes. The product is C2H5OH and you are getting CO2+. Well, here you are getting dilute alcohol. Now we have to balance the equation. See the proportion of hydrogen and oxygen. Well, here it must be 2 times and here it is 2 times because the number of hydrogen atoms are 12. So 6 into 2, 12. Number of carbon atoms are 4 and 2, it is 6. About 10% of alcohol is formed in the process. This on distillation, you are getting 95.5% alcohol called rectified spirit. About 10% of alcohol is nothing but ethyl alcohol is obtained, which on fractional distillation gives 95.5% alcohol called rectified spirit. So certified spirit, 95.5% ethyl alcohol or alcohol is called rectified spirit. Well, in the manufacture of ethyl alcohol from molasses contains about 50% of sucrose. It is non-crystallizable. It is diluted to water. Yeast is added. It secretes enzymes, invertase and gymnase. This mixture is total mixture, that is molasses and yeast. That mixture is kept for 3 days at about 30 degrees Celsius for fermentation. So fermentation takes place to give alcohol. That fermentation takes place in 2 steps in presence of enzyme invertase. In presence of enzyme invertase, sucrose is hydrolyzed to give glucose and fructose. So this is sucrose. It gives the glucose and fructose. Then glucose and fructose are converted into ethyl alcohol in presence of enzymes. Well, in this process, around 10% of ethyl alcohol is obtained, which on fractional distillation gives 95.5% ethyl alcohol called rectified spirit. Then we have about denatured alcohol. Alcohol which is unfit for drinking is called denatured alcohol, and it is obtained by mixing commercial alcohol with methyl alcohol. It acts as a poison. Little copper sulfate as coloring agent, and also some amount of pyridine which has a foul smell or bad smell. That mixture is nothing but a denatured alcohol. Then you are also using alcohol, that's ethyl alcohol, as a fuel for the motor. Not directly, but mixing with petrol. That mixture is called power alcohol. Power alcohol is a mixture of petrol and absorbed ethyl alcohol in the ratio 80 to 20 or 80% and 20% with a little benzene. So it is about denatured alcohol and power alcohol. denatured alcohol. Denatured alcohol. Commercial alcohol mixed with copper sulfate, is a coloring agent, because we know we are blue color for copper coloring agent. Then methanol, only about 5%, act as poison. As we know, methanol is poison, and little pyridine, we know it has a bad smell, bad odor or smell. Commercial alcohol mixed with copper sulfate, methanol which acts as poison, and little pyridine, and it is having a bad odor, is called denatured alcohol. Then it is power alcohol. Power alcohol. Power alcohol is nothing but petrol, 80%, and absolute ethyl alcohol. Or simply you can write ethyl alcohol because it is nothing but absolute only, 20%, with a little trace, with a little benzene. Is called power alcohol. It's called power alcohol. It is used for motor fuel. One of the use of alcohol is in the manufacture of power alcohol, and second, it's also used in beverages, that is for drinking purpose, and also another use of alcohol is used as a salt. So this is about alcohols. In alcohols, what you have to remember is about classification of alcohols, nomenclature of alcohols, then preparation of alcohols, after preparation, physical properties of alcohols, then chemical properties of alcohols. So you have to write a note on all these. You can remember easily by writing the notes on alcohols, and especially it's based on classification and also the preparation properties. First one is, remember classification of alcohols. You have to write like this on paper and try to remind all the things. So classification based on the number of OH group, it is monohydric, dihydric, polyhydric alcohols. Then to which type of carbon that OH group is attached, whether to the sp3 or to the sp2. So afterwards, it is about nomenclature of alcohols. Nomenclature for the common system, what you have to see, whether it's a primary or normal alcohol. The question arises when we have 3 or more carbon atoms in the molecule, then secondary alcohol or tertiary alcohol or isoalcohols. So for the primary, in trivial system it is called N or normal alcohol. For example, N-propyl alcohol, 3 carbons we have. Primary means CH2, OH is attached to CH2. For secondary, OH is attached to secondary carbon or CH. And for tertiary, OH is attached to the carbon which do not contain any hydrogen atom. Well, afterwards, it's a iso. We know iso means CH attached to 2CH3. Means the CH group is attached by 2CH3 group is called iso. So we can identify isoalcohols also. For example, isopropyl alcohol, isobutyl alcohol, etc. And in nomenclature, in the IPSC system, I have to say the numbering of carbon is important. Let's say how many carbons are there in the long chain. Select the long chain. That long chain must include the functional group or it is OH group. So in that way you have to remember. Second point is after classification, nomenclature. Like this you have to remember nomenclature. We have two way of naming. One is trivial or common name and another is IUPAC. Third one, preparation. So in preparation of alcohols, we have different methods. One is from alkene. In alkene we have 2 methods. Well, the simple method is by hydration of alkene, that is alkene is passed into the direct H2SO4 or into the water in presence of H2SO4. You are getting alcohol. Addition takes place according to Markovnikov rule. Then hydroboration and oxidation of the alkene. So first involve the hydroboration. In hydroboration, alkene is treated with diborane. The product formed is trialkyl borane. That trialkyl borane is then oxidized by hydrogen peroxide in presence of alkali to give the alcohol. So that's the second method from alkene. Then third method from carbonyl compounds. So carbonyl compounds. We know the meaning of carbonyl. C double bond O is carbonyl. C double bond O you have to convert into CH2, OH. How it can be done? It can be done by adding hydrogen. So from the carbonyl compound, just you have to add H2. How H2 can be added? It is not easy to add H2. For example, if you have aldehydes and ketones are converted into primary alcohol and secondary alcohol by a process called hydrogenation. Hydrogenation takes place in presence of catalyst nickel, platinum or palladium. Remember this point. Well, we have also the carbonyl group in carboxylic acid or C double bond OH. That means we have carbonyl group in carboxylic acid. But the addition of hydrogen is not easy. We cannot convert carboxylic acid into alcohol by a process called hydrogenation in presence of nickel catalyst or in presence of some other catalyst like platinum or palladium. You have to use powerful reducing agent to convert carboxylic acid into alcohol. A powerful reducing agent LiAlH4 is used, followed by acid hydrolysis, and that reaction takes place in presence of THF, tetrahydrofuran. So primary alcohol is obtained by hydrogenation of aldehyde. Secondary alcohol obtained by hydrogenation of ketone and reduction of carboxylic acid gives primary alcohol. You have to use powerful oxidizing agent like NaOH4. So this is the second method. Third method is, it is from Grignard reagent. From Grignard reagent. Well, Grignard reagent is nothing but RMGX. This is ethyl magnesium halide. We can prepare all three types of alcohols, that is 1 degree, 2 degree and 3 degree alcohols by using Grignard reagent. Primary alcohol is obtained by treating Grignard reagent with formaldehyde. So we have RMGX and formaldehyde, H double bond OH formaldehyde. Addition takes place. We know this part carrying negative charge and Mg add to this one. Addition takes place. You are getting the first product. You can write like this, first product, and this on hydrolysis in presence of acid gives primary alcohol or 1 degree alcohol. Then secondary alcohol, instead of formaldehyde, if other aldehydes are used, aldehyde other than formaldehyde, when react with Grignard reagent followed by hydrolysis, gives secondary alcohol. I am writing RMGX and R dash C double bond OH. We know this aldehyde general formula. This is formaldehyde. This is aldehyde. So the product obtained is secondary alcohol. Addition takes place. Same process. Remember, it's very easy to write the equation. MgX add to this one. So the final product followed by hydrolysis, you are getting 2 degree alcohol. And the tertiary alcohol is obtained by treating RMGX with ketone C double bond O R dash or R dash dash. Here R links to the carbon because the electron movement takes place here. Pi electron move towards electronegative oxygen atom and Mg is positively charged, add to this one. Then you are getting addition product, then on hydrolysis gives 3 degree alcohol. So this is about the preparation of alcohols from alkenes, from carbonyl compounds and by using Grignard reagent. Well, the next comes, it is about properties. In physical properties we have number 1 about boiling point, then solubility. We know boiling point depends on molecular mass. As the molecular mass increase or there is a greater number of carbon atoms, then there is greater attraction and the boiling point also increase. So boiling point also depends on branching of the carbon. There is a greater branching, then boiling point decrease because of decrease in the surface area. So surface area decrease means interaction decrease, van der Waals interaction decrease. Well, afterwards, the boiling point of alcohols is greater than ether, greater than haloalkanes, greater than hydrocarbons of comparable molecular mass. We know this is due to intermolecular hydrogen bonding. Association of H2O with this alcohol molecule takes place and we need more energy to spread the hydrogen bond. So boiling point increases. Such hydrogen bond is not there in case of the hydrocarbons, haloalkanes and also the ethers. About solubility, alcohols are soluble in water. Again, it is due to hydrogen bonding with water. There it is intermolecular between the alcohols. The alcohol molecules get interacted or get bonded through the hydrogen bond. Here it forms hydrogen bond with water. Which one? Alcohol forms hydrogen bond with water. So alcohols are soluble in water. But when the hydrophobic group is larger, that is alkyl or aryl group is larger, then solubility decrease. So solubility also depends on the hydrophobic, the length or the size of the hydrophobic group. If it is smaller, dissolves. If it is larger, insoluble or slightly soluble in the water. Then in chemical properties. So in chemical properties, we know it involves the first one, cleavage or breaking of OH bond. In chemical, we have cleavage of OH bond. Cleavage of OH bond. So in cleavage of OH bond, first one is acidic property. Acidic property. We know acid is a substance which reacts with the metals to liberate hydrogen. Alcohols act as acid because they dissolve in the, they liberate hydrogen when treated with the metal like sodium or with the aluminum. Well, acidic nature of alcohol is due to the polar bond, that's OH bond is polar. Due to that polar character, it acts as an acid. But the acidic strength of alcohol depends on how many the electron donating group is present on the alcohol. If you have greater number of electron donating or releasing group, then the alkoxide ion form will become less stable. So acidic strength decrease. For example, we have methyl alcohol, ethyl alcohol, isopropyl alcohol, then tertiary methyl alcohol. Among all these, the more acidic is methyl alcohol. Why it's more acidic? Because in case of methyl alcohol, we have only CH3 group. Afterwards, in acidic property, second one is we have this dehydration. Cleavage of OH means it's not dehydration. Esterification. So in esterification, there are three types. One is directly treating alcohol with carboxylic acid in presence of concentrated H2SO4. Second, acetylation, and then treating with acetic anhydride esters are formed. Third property is after cleavage of OH bond, it's a cleavage of CO bond. CO bond. So in cleavage of CO bond, the first one is dehydration. Dehydration involves the cleavage of CO bond. Then it's a reaction with Lucas reagent. Reaction with Lucas reagent. And afterwards, so we have next property. 1, 2. Third one is oxidation. In oxidation, you have to remember oxidizing agent. What type of oxidizing agent you are using? Fourth one, dehydrogenation. So all these things you have to remember. Some students asked whether separate note is required or not. This much is sufficient. What I am writing on the board, that much is sufficient from the point of examination. ಸರಿ ಕನ್ನಡ ಮೀಡಿಯಮ್ದವ್ರಿಗೆ ಸರ್ ನೋಟ್ಸ್ ಅಂತ ಕೇಳ್ತಾ ಇರ್ತಾರೆ. ಏನು ಬೇಜಾರು ಮಾಡ್ಬೋದಲ್ಲ, ನೀವು ಬೇಕಾದ್ರೆ ಓಲ್ಡ್ ಕ್ವಶನ್ ಪೇಪರ್ ನೋಡ್ರಿ, ಏನು ನಾನು ಬೋರ್ಡ್ ಮೇಲೆ ಬರಿತೇನೆ ಅಷ್ಟೇ ನೀವು ಕರೆಕ್ಟಾಗಿ ಬರ್ಕೊಂಡು ಸ್ಟಡಿ ಮಾಡಿಕೊಂಡ್ರೆ ಸಾಕು. ಅದು ಬಿಟ್ಟು ಬೇರೆ ಕ್ವಶನ್ಸ್ ಬರೋದು. ನೀವು ಬೇಕಾದ್ರೆ ಯಾವುದೇ ಓಲ್ಡ್ ಕ್ವಶನ್ ಪೇಪರ್ ತೆಗೀರಿ, ಯಾವುದೇ ವರ್ಷದ ಪೇಪರ್ ತೆಗೀರಿ, ಅದಕ್ಕೆ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಹೆಚ್ಚಿಗೆ ಬೇಕಂತೆ. ಇವನ್ ಮೆಕ್ಯಾನಿಸಮ್ದಲ್ಲಿ ಕೂಡ ಹೆಚ್ಚು ಕಡಿಮೆ ಬರ್ತಾ ಇರುತ್ತೆ. ಮೆಕ್ಯಾನಿಸಮ್ 3 ಮಾರ್ಕ್ಸ್ 3 ಮಾರ್ಕ್ಸ್ ಇರುತ್ತೆ. ಅದಕ್ಕೆ 3 ಸ್ಟೆಪ್ ಇದ್ದಾವೆ. 3 ಸ್ಟೆಪ್ಪಿಗೆ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಬೇಡ, ಸ್ಟೆಪ್ ಕರೆಕ್ಟ್ ಬರೆದ್ರಾಯ್ತು. ರೈಟ್ ಟು ಕರೆಕ್ಟ್ ಆಲ್ ದ 3 ಸ್ಟೆಪ್ಸ್. ಫಸ್ಟ್ ಒನ್ ಇಸ್ ಪ್ರೋಟೋನೇಷನ್. ಮೊದಲನೇ ಸ್ಟೆಪ್ ಪ್ರೋಟೋನೇಷನ್. ಪ್ರೋಟೋನೇಷನ್ ಆದಾಗ ಇಕ್ವೇಷನ್ ಕರೆಕ್ಟ್ ಬರೀಬೇಕು. ಚಾರ್ಜ್ ಯಾವ ಐಟಮ್ ಮೇಲೆ ಬರೀಬೇಕು ಅದೇ ಐಟಮ್ ಮೇಲೆ ಬರೀಬೇಕು, ಎಲ್ಲೋ ಬರಲಿಕ್ಕೆ ಬರಲ್ಲ. ನಾನು ಯಾವ ಟೈಪ್ ಕೊಟ್ಟೇನೆ ಅದನ್ನು ಸರಿಯಾಗಿ ಮಾಡಿ. ಯು ಮಸ್ಟ್ ಬಿ ಪರ್ಫೆಕ್ಟ್ ಇನ್ ದ್ಯಾಟ್. ಸೆಕೆಂಡ್, ಇಟ್ಸ್ ಅ ಫಾರ್ಮೇಷನ್ ಆಫ್ ಕಾರ್ಬೋಕೆಟಾಯಿನ್. H2O ಹೋದ್ಮೇಲೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಕಾರ್ಬನ್ ಮೇಲೆ ಬರುತ್ತೆ. ಅಂದರೆ 2 ಕಾರ್ಬನ್ ಇರುತ್ತೆ. ಈ ethyl alcohol ದಲ್ಲಿ you have 2 carbon in ethyl alcohol, you have to see on which carbon you have to write the plus charge. Don't get confused with this plus charge, carbocation plus charge and one more product H2, that plus. So I rounded that one. ಹಾಗಾಗಿ ರೌಂಡ್ ಅಪ್ ಮಾಡಿದ್ದೀನಿ. ಅದು ಬರೀಲೇಬೇಕು, ಅದರ ಮೇಲೆ ಬರೀಬೇಕು. ಥರ್ಡ್ ಎಲಿಮಿನೇಷನ್ ಆಫ್ ಹೈಡ್ರೋಜನ್. ಈ 3 ಸ್ಟೆಪ್, ಅದರಲ್ಲಿ ಸ್ಪೆಸಿಫಿಕ್ ಆಗಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಎಲ್ಲಿ ಬರೀಬೇಕು ಅಲ್ಲೇ ಬರೀಬೇಕು. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಫಸ್ಟ್ ಸ್ಟೆಪ್ನಲ್ಲಿ ಪ್ರೋಟೋನೇಷನ್ ಬರೋ ಪ್ಲಸ್ ಚಾರ್ಜ್ ಆಕ್ಸಿಜನ್ ಬರ್ತೀರಿ ಸರಿ. 2ನೇ ಸ್ಟೆಪ್ ಬರೀಬೇಕಾದ್ರೆ ಅಲ್ಲಿ ಆಕ್ಸಿಜನ್ ಮೇಲೆ ಪ್ಲಸ್ ಚಾರ್ಜ್ ಬರೋದು ಬಿಟ್ಬಿಡ್ತೀರಿ ನೀವು, ಅಲ್ಲಿ ಬೇಕಾಗುತ್ತೆ, ಇಲ್ಲಾಂದ್ರೆ ಮಾರ್ಕ್ಸ್ ಹೋಗುತ್ತೆ. 3ನೇ ಸ್ಟೆಪ್ನಲ್ಲೂ ಹಂಗೆ ಕಾರ್ಬೋಕೇಟೈನ್ ಇದ್ದಾಗ ಈ ಕಡೆ ಲೆಫ್ಟ್ ಸೈಡ್ಗೆ 3ನೇ ಸ್ಟೆಪ್ನಲ್ಲಿ ಕಾರ್ಬೋಕೇಟೈನ್ ಪ್ಲಸ್ ಚಾರ್ಜ್ ಅಲ್ಲಿ ಬೇಕು, ಅಲ್ಲಿ ಬರೆದು ಹಾಗೆ ಬರೆದ್ಬಿಟ್ರೆ ಮಾರ್ಕ್ಸ್ ಹೋಗುತ್ತೆ. ಹಾಗಾಗಿ ಕರೆಕ್ಟಾಗಿ ಏನು ಬೇಕಂತಿಲ್ಲ. ನಿಮಗೇನೋ ಡಿಫಿಕಲ್ಟಿ ಬಂತು ಮತ್ತೊಮ್ಮೆ ವಿಡಿಯೋ ನೋಡೋದು, ಎಲ್ಲ ನೋಟ್ಸ್ ಕರೆಕ್ಟಾಗಿ ಬರೀರಿ. ಆಲ್ ಆಫ್ ಯು ರೈಟ್ ದ ನೋಟ್ಸ್ ವಾಟ್ ಆಸ್ ರಿಟನ್ ಆನ್ ದ ಬೋರ್ಡ್ ಆ್ಯಂಡ್ ಇಫ್ ಎನಿ ಡಿಫಿಕಲ್ಟಿ ಅರೈಸ್ ಜಸ್ಟ್ ಟು ಸಿ ದ ವಿಡಿಯೋ ನೋಡಿದ್ರೆ ಸಾಕು. ದಟ್ ಮೀನ್ಸ್ ಇಸ್ ವೆಲ್, ದಿಸ್ ಕಂಪ್ಲೀಟ್ಸ್ ದಿ alcohols. The next topic is phenols.